All right, section 7.2 part 1 is on lots of different things. So exponential and log functions and then inverse trig functions. All right, so I think you guys know that when you integrate e to the x, you get itself, e to the x. Just like when you take the derivative of e to the x, you get itself. So I had to do 7.2 part 2 first because I realized that was the substitution method, and I put a lot of those problems in here. So number 1 is the substitution method problem. Do you guys see it? What do you think you let u be on number 1? Negative 2x, right? So du is negative 2 dx. So you have negative 1/2 du equals dx. All right, this is a definite integral, so there's numbers. So I would find what u of 0 is and u of 4 and change your numbers. You guys good? All right, so u of 0 is negative 2 times 0, so 0. U of 4 is negative 2 times 4, so negative 8. So we have from 0 to negative 8, e to the u du, with a negative 1/2 out front from the negative 1/2 du. So when we integrate, we get e to the u going from 0 to negative 8. So we're going to find that, and we're going to multiply by negative 1/2. You could also have the negative 1/2 in the parentheses, it doesn't matter. So I have negative 1/2 e to the negative 8 minus e to the 0. Anything to the 0 power is 1. So that's our answer. Okay, this ends up being a number. So e to the negative 8 minus 1, and then multiplying by negative 1/2, you get 0.4998. So I'm going to write 0.500. Notice I do not write 0.5 because it's not exactly 1/2. So I have to do 3 decimal points. So like I said, it was 0.4998322.687. That's what my calculator said. If I round to the nearest to 3 decimal places, it's 0.500. So you can write it in either way. Do not write the answers 1/2. All right, so the next one. So you get u equals 4 plus e to the x. du is e to the x dx. Okay, so that means our e to the x dx is replaced with du, and this other part is u to the 5th. So we have u to the 5th du. So when we integrate, we get u to the 6th with a 1/6 out front, plus c. We need our plus c because we don't have a definite integral. We don't have numbers, our limits of integration. So I get 1/6 times 4 plus e to the x raised to the 6 plus c. That's your answer.
First one, u of 0 and u of 4, we didn't do e to the 0 or e to the 0.
You're plugging it into the u function, right? X was
you're right.
x was 0 and x was 4.
Yeah.
So we plug it in there. All right, so next one. What do you think u is on this one? Square root of x, right? du, since square root of x is x to the 1/2, du is 1/2 x to the negative 1/2 dx. In other words, it's 1/2 times 1 over the square root of x dx. Now, if you notice in our problem, we want 1 over the square root of x. We want that. So let's multiply the 2 to the other side. So 2 du equals 1 over the square root of x dx. All right, so we get e to the u du, and we have a 2 out front from the 2 du. So we get 2 e to the u plus c. So we get 2 e to the square root of x plus c. And that's your answer. The next one, u is sine of x. So du is derivative of sine is cosine of x. which worked out perfectly because that's what we needed, cosine of x dx. So we have e to the u du again. So we integrate, it's just e to the u plus c. So our answer is e to the sine of x plus c. Okay, so obviously e to the x is very easy to integrate. We like those. All right, number 5a says, use the intermediate value theorem to show that there's a root of the equation. Do you guys remember the IVT, intermediate value theorem? What does it say? Right?
That if it crosses the two numbers and that y1 is negative and y1 other is positive, or there's a change in sign, there has to be a root.
Yep, and not only a root, I mean, it would work for any number, but we're saying y is equal to 0. So our function, we're letting f of x equal e to the x plus c, or e to the x plus x. And it is differentiable and continuous everywhere. So usually you'd need to say on the open interval if there was a certain open interval you were talking about, but this one you can take the derivative everywhere, and it's continuous everywhere. Okay, and Roshni was saying if you plug in one value, Friday 11, yeah, scared me.
Whoa!
If you plug in one value and you get a negative number out, and then you plug in another value and you get a positive number out, there has to be a root between them. So what numbers do you want to plug in? What? -1? Is that what someone said? Okay, so -1. So if we plug -1 in, we have e to the -1 plus 1. So e to the -1 plus, oh yeah, -1, thank you, plus a -1. So you get -0.632. I wrote Allie over there, but it came out AI. Allie. All right. What's another number you want to try? 0. That works. E to the 0 plus 0 isn't 0. It's 1, right? So you have a negative number and a positive number. Okay, so that means there is a 0 somewhere between 0 and -1. So this means there exists, if you want to do a shortcut. So there exists, backwards E, a 0 between -1 and 0. Okay, so let's use our graphing calculator to find it. So we're going to plug that in for our y1. So e to the x plus x. We're going to graph it. You can zoom in on that area if you need to, but you don't really. I mean, mine looks pretty good. And then you find 0. So go to second, calculate, and find the 0. So -0.567143 would be 6 decimal places. Yep, just finding the 0. That's it. So that was between -1 and 0. That's the one we're talking about. You could also talk about, would there be another 0? Are there any more? Based on the graph, it doesn't look like it comes back down, but how could you prove that it does not come back down and cross the axis again? So if I asked you on a free response problem to prove that there were no more 0s, so to prove that it's always increasing, you'd find the slope. So f prime would be e to the x plus 1, and isn't that always positive? Right? E to the x plus 1 is always positive. Anything you plug in for x is going to be a positive number in the end. Okay, so you could say, therefore, it's always increasing. So it's never going to come back down, and you're never going to have another 0. Okay, so number 6. So find the particular solution of f of x that satisfies the initial conditions. So you have f double prime, so that's the second derivative. if you can see the double prime. Okay, so we need to find f prime, and then we need to find f of x. Okay, so f prime of x. This isn't really like a separable problem because there's no y that you have to worry about, right? It's only x. Okay, so that makes it nice. Okay, so I would first rewrite f double prime of x maybe as 1/2 e to the x plus 1/2 e to the negative x. I just multiply the 1/2 in. Just makes it a little easier. So what's f prime going to be? One half e to the x minus 1/2 e to the negative x. Do you guys know how I'm getting this? Why do you have to have a minus there? It's totally Friday in this class. Because the power was negative, so if you multiplied by the chain, right, you'd have a -1. So you need that. And then plus c. The chain. You need to say it louder. I can't hear you guys.
I wasn't confident.
All right, now we were given an initial condition for f prime. We said f prime of 0 is 0, so that allows us to find c. So when you plug in 0, you have 1/2 e to the 0 minus 1/2 e to the 0 plus c. So those go away. So c is equal to 0. That little double arrow means this implies. So this implies c is equal to 0. All right, so now let's find f of x. So if f prime of x is up there, 1/2 e to the x minus 1/2 e to the negative x, what's f of x? 1/2 e to the x plus 1/2 e to the negative x. It goes back to f double prime. Plus another constant. We don't write c because we already used c, so d.
If c were equal to like 1, would we do plus 1 plus d?
What if c was equal to 1? So Catherine said, what if this was 1? So what if it was 1? Then when we integrate, this would be 1x, right? Plus d. Okay. All right, so we're given the other initial condition that f of 0 equals 1. So I have 1 equals f of 0. So if I plug in 0, which is just 0 there, plus d, what's d? D equals, no, 0, right? E to the 0 is 1, e to the 0 is 1. So this is 1/2 plus 1/2, that's already 1. So d equals 0. All right, so that means your f of x function is 1/2 e to the x, shh, guys, plus 1/2 e to the negative x. Oops, that's x. So it's the same as f double prime. Okay, so that's it. All right, so next up. So it says, notice the derivative of natural log of x is always 1/x. This gives you the integration formula for 1/x. Okay, so we've done this before. We've used this formula before. You guys know why we need the absolute value, right? You can't have natural log of a negative number, so we have to have absolute value x. All right, so in these problems, we have more u substitution problems. Sometimes, not all of them. On the first one, I'm going to let my u equal what? Shh, guys, I know it's Friday. We have things to do. What is u? No. X squared plus 1. It's the denominator. You're never going to have a du on the bottom, so usually make your denominator. Du is 2x dx, which gives you the x dx that you need. So that part's du with the 1/2 up front. All right, so we have 1/2. We have the du part, and then we have 1/u. So when we integrate, we get 1/2 natural log of the absolute value of u plus c. So it's 1/2 natural log of the absolute value of x squared plus 1 plus c. Now you can really impress your AP graders if you guys know that you do not need absolute values here. Why? X squared plus 1 is always positive. So if you really want to impress them, go to the second step, which is this. So write it like that. So know when you need them, know when you don't. If it had been x squared minus 1, would you need them? Yes. Because if x was 0, that'd be a negative number, right? Okay. So next one, so maybe some of you are thinking that you need a u substitution here, which is weird because you have u, so you'd have to use another variable like w. But you do not actually need a u substitution on this one. What do you do? Can't just integrate from here. You have to simplify. You what? Yep. So since you have this on the bottom, you bring it into both pieces. So 1 to 2, you have 4u to the negative 3. Plus, if you had u squared over u cubed, that'd be 1 over u, right? So you can write u to the negative 1 or 1 over u du. So when we integrate, you can, a lot of you guys like to bring the, like you could rewrite it as 4, 1 to 2, u to the negative 3, du, plus u to the negative 1, du. But you see how that's just writing a bunch of stuff that you don't need to write? You can integrate. I mean, you can do this in your head without doing that. So if I have a 4u to the negative 3, I'm going to add 1 to the power, so I have negative 2. What number would I need out front to multiply to be negative, or multiply to be 4? Negative 2. Or you could think of it as 4 times, and you do 1 over the new power, like that, if you can't do that in your head. All right, plus, the second part's going to be natural log of the absolute value of u, and you're going to go from 1 to 2. So you get negative 2 times 1 over u squared plus natural log of the absolute value of u, and we're going from 1 to 2. So plug in 2 and then plug in 1 and then subtract the 2. So when I plug in 2, you get 1 over 2 squared, so 1 over 4 times the negative 2, so negative 1/2 plus natural log of 2 minus, you don't need absolute values there too because it's just natural log of 2, right? Minus, when you plug in 1, you get negative 2 plus natural log of 1. Natural log of 1 is just 0, so it goes away. So you have negative 1/2 plus 2, because you have negative 2. So 2 minus 1/2 is 1.5, so 3 over 2. So you get 3 over 2 plus natural log of 2. And that's your answer. If you wanted the decimal form, you could do 3 over 2 plus natural log of 2. You'd get 2.193. You'd also have that answer. Decimal form would be good to have if it was on the calculator section because you could always use Math 9 to find that, right? So, all right, so sine of x over cosine of x dx. We know that's tangent, but we don't know anything that when we take the derivative of it, we get tangent out. Okay, so we have to do u substitution. So what are we going to let u be, sine or cosine? Cosine, right? We let it be the denominator. So u equals cosine of x. So du equals negative sine of x dx. So you have negative 1 over u du. So negative natural log of the absolute value of u plus c. So it's negative natural log of the absolute value of cosine of x plus c. Okay. But if you notice in your little box on your page right below there, you have tangent of x dx equals natural log of secant x plus c. How's ours different? So we have negative natural log of cosine of x. What's the difference? How are cosine and secant related? 1 over. Okay, and the other thing is different. We have a minus, not a plus. So let's say I had a minus 1. Do you guys remember if you have natural log, you can bring numbers out front as powers. So there'd be natural log of cosine of x to the negative 1 plus c. Now that's not inverse cosine, that's saying raise your cosine to the negative 1 power. Okay, so that is secant. So it's natural log of secant of x plus c. Yeah, Dana?
How do you tell like the difference between like whether it's raised to
Because we weren't taking the inverse of cosine. We weren't like solving an equation. Like if I had, what was it? So let's say I had cosine of y equals 1/2. When we solve that, we take the inverse of cosine. We have to get rid of cosine, so we do arc cosine, like that. So we weren't doing that. We were raising it to a power. So raising things to a power is 1 over. Yeah.
Did you say that you made the denominator all the time?
Not all the time, but try that first, yeah. All right, so I hope that you guys know those ones already. So I hope that you know the how to integrate e to the x and how to integrate 1 over x. You know those already. This is one that you do not know. This is one you need to memorize. You need to know this cold. Okay, do you guys remember when you had y equals a to the x? Well, y prime was a to the x natural log of a. Natural log of a is a number. Okay, so just like when you had like y equals cosine of 2x and you took the derivative, you had y prime equals negative sine of 2x times 2. But now when we're integrating, if I have cosine of 2x, we had a 1/2 out front. So we did 1/2 sine of 2x plus c. Do you guys know what I'm getting at? So if we're integrating a to the x, so if we're going backwards, we need to divide by the natural log of a. Okay, so it's kind of doing the opposite of what you did before. Okay, don't get those confused. So you need to know how to take the derivative at a to the x, and you need to know how to integrate. Do not confuse them. It would be disastrous on your AP exam. Is a to the x natural log of a. Yeah, so if you had the derivative of a to the x, it's a to the x natural log of a. Okay, so number 1, so I have evaluate the integral from 2 to 5 of 3 to the x dx. Okay, so it's just 3 to the x over natural log of 3 going from 2 to 5. So it's 3 to the 5th over natural log of 3 minus 3 to the 2nd. And these are numbers, 243 minus 9 all over natural log of 3. So it's 234 over natural log of 3. So if you wanted the decimal version, like if you didn't like that, it'd be 212.996. So either answer is fine. Is it going? I'm trying to go to the next page. It's not letting me. All right, trig functions. All right, do you guys remember when we talked about the derivatives of inverse sine and inverse tangent? Do you guys remember those? Yeah, so those were the two that I told you were important. So you need to know this one and this one. These are the only two that I've ever seen on the AP exam. The BC exams are a little different. I mean, maybe you have to know more on that, but yeah. I know. So these are the only ones I've ever seen on the AP exam. And they are correlated. I mean, that was the derivative, right? So when we integrate, these are the ones we need to know, which is just the opposite. So you know the derivatives already, hopefully. Remember how we had our little quizzes all the time? Hopefully you know those. Do I need to do another quiz? So when you say no like that, it usually means yes, I need to do another quiz.
I mean, if you want to.
We also go pretty fast.
Yeah. All right, so prove the identity. So inverse tangent of x plus cotangent of x equals pi over 2. Okay, so you can actually do proofs in calculus using derivatives or integrals. So yeah, you can. It's crazy. All right, so let's say let's let our function. So let f of x equal inverse tangent of x plus cotangent inverse cotangent of x. Okay, if I was finding f prime of x, inverse tangent was 1 over, anybody remember? Yep. Cotangent of x, let's go back to your chart. I didn't have you memorize that one. It's just the opposite, right? So it's negative 1 over 1 plus x squared. So that means that when you add them together, you get 0. Therefore, if f prime of x equals 0, f of x equals, when you integrate, what gives you a derivative of 0? No. A constant, right? A number gives you a derivative of 0. So that means inverse tangent of x plus cotangent of x, which was f of x, equals some constant. So we can find that constant by plugging in anything for x. So good things to plug in for x when you have tangent and cotangent. I would say pi over 4. Why is pi over 4 nice? So think about your unit circle. At pi over 4, you have square root of 2 over 2, comma, square root of 2 over 2. So what's the tangent? 1. What's the cotangent? 1. So we have, well, I guess we're plugging in x equals 1. So plug in x equals 1, because we're going inverse tangent of 1 equals something. That's the same as saying tangent of that something equals 1. So we want pi over 4. So inverse tangent of 1 plus inverse cotangent of 1 equals my constant. So that's pi over 4 plus pi over 4 equals the constant. So our constant has to be pi over 2. And it will work for anything that you plug in for x. So if you plugged in x equals 0, so if you plug in 0, you'd have 1 comma 0. So tangent would be 0. Well, I guess that'd be undefined. So you have to kind of pick your numbers. All right.
How do you know to pick pi over 4?
You can pick anything. Pi over 4 is just nice with tangent, because tangent of pi over 4 is 1. All right, so here's what's important on these ones. So when you're integrating, so you'll see these on your multiple choice questions every now and then. All right, it looks almost looks like that one, which hopefully you guys know is related to inverse sine. When you integrate it, you get inverse sine. All right, those are the two I want you to know. So how can we definitely get it to look like that? What U substitution could we make?
4x.
Not 4x, close. What's being squared? 2x. Light bulb moment. Okay, so that means that, right, this in here was 2x being squared. So that's our U squared. So we now have 1 over the square root of 1 minus U squared du with a 1/2 out front. And if we're changing them to u's, our numbers should change as well, our limits of integration. So we need to find what u of 0 is and what u of 1/2 is.
Why did we do it this way?
Because we need it to look like this. We need 1 minus x squared under the square root, or 1 minus u squared. All right, so u of 0 is 0. U of 1/2 is 1, so we're going from 0 to 1. Okay, so I have 1/2 inverse sine of u going from 0 to 1. Okay, so what this means when we're doing inverse sine, Mr. Syek was just doing this in pre-calc yesterday. If I'm finding inverse sine of 1, you're saying what on your unit circle gives you a sine value of 1, and it's restricted to this domain. So it can only be between those values. So what gives you a sign of, well, it's negative pi over 2 to pi over 2, I guess I should write. So between negative pi over 2 and pi over 2, what gives you a sign value of 1? Pi over 2. Okay, for the other one, you're saying if you have the inverse sign of 0, what gives you a sign value of 0? 0. So you have 1/2 on the outside. You're going to have sine, inverse sign of 1, which is pi over 2, minus inverse sign of 0, which is 0. So you get pi over 4 for your answer. Okay, so same kind of setup here. You want it to be, it's almost in the form, so we want it to be in the form 1 over x squared plus 1. Do you see how it's kind of in that form? Not really. Yeah, it's hard. This one's a really hard one. Luckily, these ones are very rare on the multiple choice.
You just see whatever is closest.
Yeah, think of inverse sine or inverse tangent and decide which one it's closest to. It's not the sine because it doesn't have the square root. So it's inverse tangent. Okay, here's what we do. So we want 1, first of all. We don't want 9. So I'm going to pull out 1 over 9 first. Yep. Is it 9x? No, it would be 1 over 9x to the 4th. Is that right? 1 over 9x to the 4th plus 1. Okay. Now we know we're going to use a u substitution somehow. So we want this to be u squared. So what does u have to be? What? There's an x squared in it. What else? 1/3. Was that Cyric? 1/3. 1/3 x squared. Do you guys see? Because when you square that value, you get 1/9 x to the 4th. Okay, so du is 1/3 times 2x, so 2/3 x dx. So that means I'd have 3 over 2 du equals x dx. So we have the 1/9 out front, we have a 3 over 2 out front. We have the x dx is replaced with the du. So I have 1 over u squared plus 1 now. Sorry, I'll hurry. So you get 1/6 inverse tangent of u. So u was the x squared over 3 plus c. So that's your answer. Did I replace the u in the last one? Oh yeah, we didn't have to, right? Those numbers. All right, so that's your answer. All right, so you should be able to finish all your homework now.